Welcome to the Mission Observer, familiarization and preparatory training. I'm First Lieutenant Gregory Carr with the Seacoast Composite Squadron of the New Hampshire Wing. After completing this presentation, you should review the material with an evaluator so that you can be signed off, moved on to more advanced training. Before we get started, let's make sure that we're ready for the training. You should have completed your General Emergency Services course. Also, you should have completed your Mission Scanner qualification. You should be age 18 or older and should have received commander approval for the prerequisites. This training is based on the Mission Aircrew Task Guide. The task guide can be accessed at the link below for this training as well as further, more advanced Mission Aircrew training. Now let's go over our learning objectives. First, we'll discuss our Mission Observer duties. We'll talk about using in-flight services, plotting a route on a sectional, preparing a trip to a remote mission base, discuss the dangers of icing, the dangers of reduced visibility, the dangers of wind and thunderstorms, the effects of density altitude on aircraft performance, and we'll identify control and special use airspace on a sectional. Let's go over the Mission Observer duties. Mission Observer duties may well include receiving the mission briefing with the mission pilot, assisting in planning the mission, assisting in avoiding obstacles during taxiing, operating and setting up the navigation and communication radios, monitoring engine and fuel gauges, coordination with mission base via the FM radio, and maintaining chronological flight logs. Next, let's discuss in-flight services provided by the Flight Service Station. The Flight Service Station provides weather and thunderstorm information on our route or in the area we may be operating. They also report PIREPs, or pilot reports on weather phenomenon. The Flight Service Station, denoted as Flight Watch, can typically be reached on frequencies beginning with 122. You can find the Flight Service Station frequency on the upper left-hand corner of the NavAid identifier on your sectional chart. You may also find that the Flight Service Station receives on one frequency and transmit on a different frequency. This situation would be denoted by the letter R after the frequency, indicating they receive on this frequency, and they'll transmit on the VOR voice function. In the case of the Augusta VOR, the Flight Service Station would receive on 122.1 and it would transmit on 114.905. Another in-flight service we often utilize is the Automatic Terminal Information System, also known as ATIS. This terminal information is broadcast on a frequency found in the sectional with the other information on the airport. Some specifics about ATIS. ATIS is typically only found at towered airports. It contains airport-specific weather and notices. It's updated hourly and during special weather changes. It's also identified by letter for currency. So you'll often hear information Lima. When this information becomes non-current, it'll be replaced by information Mike. Similar to the ATIS, another in-flight service is the Automatic Weather Observation System, or AWOS, also sometimes referred to as ASOS. The AWOS or ASOS frequency can be found with the other airport information on the sectional chart for non-towered airports. This service also provides airport-specific weather and notices. Typically, ASOS and AWOS are updated constantly by an automated system. A few more details about some of the in-flight services we mentioned. ASOS and AWOS can also be accessed by telephone. The information provided would be the same information as received over the frequency. Also, pilot reports are typically provided via tower or flight service stations, but they can also be done directly between landing and departing aircraft on the common traffic frequency for an uncontrolled airport. Now, let's look at plotting a route on a sectional chart. Plotting a route on a sectional chart is typically going to be done by the pilot. However, you may be assisting the pilot and should understand how this is accomplished. And depending on the circumstances, the pilot may ask you to plot the route for the mission. We're going to begin by using a scaled protractor specifically made for the sectional aviation chart. Using the protractor, we'll draw a line between our departure and arrival airports, in this case, Laconia and Lebanon, New Hampshire. Next, we need to determine the heading for our route. To do this, align the ruler portion of the protractor to either a latitudinal or longitudinal line which crosses our route. We can then read our heading or our bearing from the protractor where the line intersects the protractor. We also must take into account magnetic variation. This value can be found on the sectional chart as a dashed line nearest to our route. If this number is designated as east, we will subtract it from our heading. If it's designated as west, we'll add it to our heading. For non-pilots, this can seem like a very complicated process. Rest assured, you'll be given lots of opportunity for practice and much more information in the more advanced training. Finally, let's locate a few visual waypoints along our route. Typically, you want to make these waypoints close enough apart so that you can see the next one from the one that you're at. You also want to utilize large structures or geographical features like airports, towers, or large cities. Here we'll mark off 4 waypoints and write down the distance between each using the ruler portion of our sectional ruler protractor. Now let's talk about preparing for a trip to a remote mission base. Remote missions may involve long days or possibly overnight or nights. It might be in support of hurricane recovery, supporting wildfires, or it could even be recovery support for nor'easters, Maine, New Hampshire, or Vermont, as we did in Hurricane Sandy and Katrina. The Mission Observer Section 2107 has a detailed checklist which you might find very helpful when packing for these events. Typically, you want to consider uniforms and credentials, including line badges, cap ID, driver's license, possibly even a passport. Your personal equipment as a pilot, observer, or scanner, aircraft equipment, including tools or navigation systems. And as with any flight, you must consider your FAA weather briefing, cap flight release, and your pre-flight. Now let's talk about the dangers of icing. Ice and hard-packed snow can build up on the surfaces of an aircraft in flight or on the ground. It's very important that we understand how ice and hard-packed snow affect aircraft performance. Typically, when we're flying, if we notice ice building up on any of the surfaces, including tires, struts, wing leading edges, we want to alert the pilot immediately so that we can take corrective action. If we head out to the aircraft for a mission and notice ice or hard-packed snow has built up on any of the surfaces, we need to immediately take action to remove it. It's important to know that icing affects all features of aerodynamics. The lift decreases as the ice starts to change the shape of the airfoil. Also, thrust decreases because the engine has to pull a much heavier weight. Obviously, weight increases as ice gathers on the surfaces. And finally, drag increases due to increased weight and the surface roughness of the ice. Another critical effect is the stall speed of the aircraft increases due to the changes of the weight and balance of the aircraft from the accumulating ice. Finally, it is very important to remember the effects of icing are cumulative. Each effect adds its own decrease to the performance of the aircraft. For all these reasons, if we ever see ice accumulating on the aircraft in flight, we must immediately take corrective action. And if we ever see ice on the aircraft during pre-flight, we can't take off in that aircraft until it's all cleared. And remember, if these concepts seem a little bit complex, you'll have plenty of time to go over them with your instructor. Let's talk next about the dangers of reduced visibility. One form of reduced visibility is fog. Fog typically forms when the temperature and dew point are within approximately 4 degrees of each other. It makes it very difficult to see landing runways. It can make it difficult to see search areas. It also makes it very difficult to see traffic in the area in which you're flying. Another phenomenon which reduces visibility is haze. Haze is a fine smoke-like dust. It also makes it difficult to see landing runways, search areas, and traffic in the area. Typically, haze will occur later in the day and be exacerbated by a setting sun. Now let's talk about the dangers of wind and thunderstorms. One of the dangers of wind and thunderstorms is convection currents. Convection currents can affect aircraft while landing and in the search pattern. Convection currents are formed by the uneven heating of the surface of the Earth. In areas prior to the runway, this can change a normal, smooth glide path to a glide path with bumpy upcurrents and unexpected turbulence. Additionally, when these get severe, it can result in significant updrafts and downdrafts, producing wind shear on final. Another way in which wind shear can form is through the downdrafts of thunderstorms meeting with background winds and creating gust fronts, pushing up on aircraft that are landing. Also, during gusty or variable winds, headwind shearing to tailwind or calm wind can also produce wind shear on final. Finally, the last danger of wind and thunderstorms, lightning. Lightning can and has struck many aircraft. While typically the occupants may not be harmed, the aircraft can receive substantial damage. In addition to the airframe, navigational systems, radios, and other electronics can all be significantly damaged. Moving on, let's talk about the effects of density altitude on the performance of the aircraft. Pressure altitude and density altitude can be formidable topics, so let's take a look at a definition. Pressure altitude is an altitude measured from the point at which an atmospheric pressure of 29.92 inches of mercury is found. A good rule of thumb is that 1,000-foot change of altitude results in 1 inch change on a barometer. Another way to determine pressure altitude is to enter 29.92 into the altimeter window of your aircraft altimeter and read the resulting altitude indication. Now, when pressure altitude is corrected for non-standard temperature, density altitude can be determined. Yeah, this can be one of those really confusing topics. So let's look at it simply. Remember, as you move up in altitude, the air gets thinner. until you get out into outer space and the air pressure is zero, the ultimate of thinness. The thinner the air is, the harder the aircraft has to work in order to get airborne. This is because there's less air to push against for the propeller and the wings. So now let's look at two different aircraft in two different cities. One in Boston at a high sea level pressure, and one in Denver where it's 6,000 feet higher, and the air is therefore much, much thinner. The aircraft in Boston is going to take off much sooner. It's much more effective in lift and thrust. The aircraft in Denver is going to struggle quite a bit more to get airborne, putting its takeoff point much farther down the runway. Additionally, in the lower picture we see the climb out of these two aircraft is going to be much different as well. The Boston aircraft is going to climb out on a higher angle than the Denver aircraft. So the Denver aircraft may have more difficulty in clearing obstacles off the end of the runway. Now let's talk about special use airspace. Special use airspace is designated by the FAA for certain aircraft and facilities to use for special purposes. This airspace may create navigation obstacles. This airspace normally appears as irregularly shaped areas outlined by a blue or magenta line. Usually special use airspace will have named or numbered designators, and the status and schedule of areas are available through flight service. Our first special use airspace is the prohibited area. The prohibited area is shown with a hatched blue border. Flight within this area is prohibited for national security or other reasons. Here we see prohibited area P67, which is President George Bush's compound in Maine. And here we see prohibited area P56, which is the area of Washington, D.C., including the monuments and the Capitol building and the White House. The next special use airspace is a restricted area. The outline for this area is similar to the prohibited area, but the designation uses the word restricted and the identifier starts with an R. Restricted areas are typically used by military aircraft in operations including bombing and gunnery. This would make sense since this restricted area is clearly associated with Fort Devens to the north. What may be confusing is they seem to be showing an arrival route going right through the restricted area. However, this restricted area only includes the altitudes from 3,000 feet to 15,000 feet. Another special use airspace is the military operations area. The markings for these areas are similar to the restricted area and prohibited area, except they're magenta instead of blue. The MOA is where military aircraft may be conducting high-speed combat training, and while VFR aircraft are not prohibited in this area, it would be prudent to contact the FAA to find out what operations are taking place and when, if you plan to transition the area. Our final topic on airspace is the military training routes. Military training routes are not classified as special use by the FAA, but they are good to watch out for. Two types of military training routes are instrument training routes, designated by IR, and visual training routes, designated by VR. Additionally, if the designation has 3 digits, the route is flown above 1,500 feet AGL, and if the route is identified in 4 digits, it is flown below 1,500 feet AGL. This concludes our familiarization and preparatory training for the mission observer position. You should review this information with your training evaluator so that he or she can answer any questions you may have. Thanks for participating in our class, and good luck with the rest of your training.